Here we are. I think we are up and running. Excellent connection. I'm only seeing a black screen, but why not? Okay, let's fade and go straight to processing. I can even big that up. I think it is running. Look at that. I have it. Where's that? So I need to go to processing and find the window. Stop it and run it again. Here we are. This is one of the processing examples that come with processing when you install processing. I'm saying processing a lot. When you install the app, um, it comes from the Java version. It's been kind of translated into Python, and it models flocking behavior in, say, birds, although fish will probably apply as well, which is something whereby the basic setup, the program itself, the main, that's main.py, is just, yeah, there's this handler when mouse pressed. Oh no, what am I doing? It's this shortcut. What have I done with the window? Let's do it again. So when I click, I can add them. Now they for some reason it's slow at the start, but it gets a little bit better. Um, Boom. Yeah, that's neater, isn't it? Right. So the main is relatively straightforward, right? It just sets up a canvas. That's the resolution. I could have it larger. This doesn't really cost me more to have it larger. I like 640. Let's make that 700, 700. Then the flock, we kind of create a flock, add some Boids in there at a random, no, in the middle, forgive me. There's some randomization elsewhere. And then that's our background. We run the flock. The flock itself, the flock class doesn't do much. It just stores an array of boids, birdoids of birds, and then passes that entire list to each individual boid in the boid list to run. And then this is where the magic happens. That's 160 lines, not too difficult. In terms of attributes, you've got your acceleration, angle, velocity, and location. We use the Processing.py vector. I say we, it's obviously not mine, right? This is Daniel Schiffman and Craig Reynolds, so thanks to them. Look at my boys, aren't they lovely? Okay, what I wanted to do here is jazz it up a bit, and I've already started doing that. So I'm going to go to Chrome and put a new window and go to Replit, le repli, as we call it en français. And I have my REPL, and I have a PyFlock. The reason I'm not doing it in REPL just to run is because it's Python that then translates into Java, and that's running into a virtual machine. In REPL, it just makes things a bit slow, particularly like when you start the script, which means that it takes a while to get to your error. All of my chains are in Boid. Actually, we can see them here. I've got quite a few. So I added some. Yeah, no, actually, I can. Well, okay, let me paste the processing. And I've lost the window. No, there it is. No, sorry, that's the window of REPL. Okay, your baseline flocking sketch, as is the name of processing programs, will create, I think, 50 to start with. Or we could make that configurable 80. Wow, that's way too much. Okay, that's another thing I done, right? So I would probably put it in here after the imports, but a little bit before. N voids is equal to 50, and then take that and make that the number we use. Although that's the thing, my machine will cope with 80, the REPL online not so much. Okay, I've lost it from my clipboard. Right. Ooh, this is 4 indented. Will that be fine? Yes, because I think I got it from here in the first place. Here, and replace all that. Oh, it's kind of updated live. This is quite impressive. So now, wow, okay, I didn't know I could do that. I think if I've got the latest of my changes. Now the colors of the voids, that's because those are the changes. Now the voids have color and the color mean things, but you have to understand the way the basic void works. So in fact I might need to, oh no, sorry, this is because I'm just looking at the replit that's running. This is the new one. The old one is over here. Ah no, it's a nightmare. I can't handle my windows. Stop it, run it again. Ooh. Ah, yes, I needed to actually pass mouse pressed throughout because only draw has mouse pressed. So flock run will take mouse pressed. Mouse press is a handler, you can define it, but the mouse press is a variable you access that's true or false when the mouse is pressed. That only happens in draw, right? So we need to pass it through the flock. So now the flock run will need to accept mouse pressed. I'm going to copy and paste my colon mouse pressed to go here. And then in the Boid, it's in run. So throughout all of the call stack. So yes, run. So that's the thing. All of the chains in Boids are done because that's Boid I pasted. The basic Boids. Let's go to Replit because that's not needed to show some code. Let's stop this because it's quite distracting actually. History and rewind. All right, your basic Boids I started with. I get 3 priorities when they flock. You have to go into flock. They work out a separation vector. So there's 3 vectors that we're gonna apply, sort of add together. That's gonna become our acceleration. One is based on separation. That is, the Boid tries to go towards the center of the flock, give or take. One is based on alignment, which is that the Boid tries to line up with its neighbors, and cohesion. Separation is maintaining a minimum distance from its neighbor. Cohesion is towards the center of the flock. Now, what I've done is I wanted to add a little bit, like at the moment in the baseline code that I took, all of the Boids are identical. So it's nice to, and even as with all identical Boids, so I think I'm running, surely I will find out very quickly which one I'm running in the output once it loads. But we still get kind of quite cool flocking. Oh yeah, I forgot the camera is on, so I couldn't hand wave. We still get quite cool flocking behavior, and it really looks like starlings or whatever, even with all of the Boids being identical. But we can jazz up that emergent modeling even more by making all of the Boids ever so slightly different. So what I went and did is I applied each Boid will be born with 3 factors that affect. Wow, okay, that's way too much. So each is born with a factor that's picked at random. That is the one that we used to weigh. We used to weigh by just 1.5, 1, and 1, and instead those are slightly random factor within a range, right? So I've told you that we can toy around with the numbers that will affect this. So that will affect the baseline behavior of each Boid will be slightly different because they'll work out a different acceleration vector because they each hold slightly different priorities with their 3 rules that I didn't rewind. The 3 rules being, again, I'll try to go towards the center of the flock. I try to keep a distance from my neighbors, and I want me and my neighbors to be pointing in the same direction. Now, what I've done in the new one is that when you click and you hold, you become a point of attraction. You kind of become like the center of the flock there. When they do their cohesion, they want to go towards you, I think. Towards the pointer, right? But, so further down in my changes in the code, so I've got my self-separation, and then what I'm doing is I'm changing the render function so that can I zoom? That's what's nice about REPL. So in render, we sort of like have a transformation matrix and draw some triangles with verts. We don't need to worry about that, right? But we fill and stroke are the colors of the fill and the stroke. So what I'd done initially was to say have the color be their current priority, the current strength of their vector, like the magnitude of the separation alignment and cohesion vector. That's render color based on separation element collision. Although we can also do it on the factors. So that means they'll take a color at birth, at instantiation, and that color won't change. And so the red ones have got for instance, a higher priority on separation, whereas like the red, green, blue, the mostly blue ones are interested in cohesion. So when I get my new code, which because it's like quite a greedy thing, so will that work now that I've changed my mouse pressed? Yes, it is. Look at that. So now my Boids have colors, and they're color coded in that like their color doesn't change throughout, as they fly. My little Boids. Let's get some more because yeah, it can cope with. I started with 50 this time, but I could have coped with 80 on my machine. So those will indicate the sort of priorities of movement. So the mostly blue will tend to want to stick with the flock, the mostly green will care about alignment and so on. We can really play with those factors. Can I zoom in? Be nice. How do I, do I want to go into processing preferences now? Create font. Whoa. Okay, for the actual processing program. Yeah, oh, that's cool. Yeah, it was originally something really for artists. It's a really neat framework to get graphic stuff and interactive stuff off the ground really quickly. Um, in fact, I wanted to do something cool with an artist friend of mine, but it doesn't run on a Raspberry Pi. However, Pygame, like Python Pygame, runs on Raspberry Pi. That's what I ended up doing. So those are my boids. And I think if I've got my event handle, look, now the mouse will attract them because I wanted to get that feeling with the flock when at the edge, like some birds reverse direction. And this is much more like a murmuration. Now it looks like the attraction only works if, okay, the attraction to the center is cohesion. And cohesion was, wow, average location of all nearby birds. So this is the thing that now our playground, to be fair, each of those methods that generate the vector based on those three rules has kind of a limit. So in cohesion is neighbor distance. So we only look at the ones that are within the neighbor distance. Now it wouldn't make too much. It wouldn't probably cost too much to have this be even 700, right? I mean, or whatever, because it's. Let's see if I crank those up. So neighbor distance will be 700. We'll just add some more vector arithmetic. I don't know. We'll find out. Here, same deal. There is a neighbor distance. So we're only looking at the alignment if we're doing the neighboring distance, not 50 pixel. Well, I can probably double that, right? And the third one is separation. Separation is about, I want to keep 25 for my neighbor. I like that. That kind of works. Is this like live updating? Because oh no, there was the REPL that surprised me. So now we have this. Does it change the behavior? You know what I'm gonna get? I'm gonna get some more. And Boids equal 80. Run it again. Oh yeah. It's interesting. The reason they're slow at the start is that we are doing much more calculation because they're all clustered together, so there are many more neighbors, right? Okay. Nice flock. Right, now they're attracted to the cursor, particularly, really the red ones? Red, green, blue, does that make sense? I was expecting the blue ones, but so far, like, it's not that you'll be able to divine, like, see their behavior. So I think I'm gonna make the edge. So I'm my Boid, I'm in render, yes. So I'm gonna go back to rendering the fill. Is it? Yes, it's the same shortcut. And instead, this is going to become the stroke. So I don't want 255 and then I'm just going to quickly go to the documentation. Stroke weight is how we call the thickness of the line. Stroke weight. Well, oh, fair enough. So that's a 1 default. Oh, 4. I'll go up to a 3, maybe not a 4, because my boys are quite small. But again, I could make them larger if I obviously went to the right window first. Okay, so stroke weight, bracket. Let's go to a 3 to start with and see how that looks like. I don't want to make bigger triangles. Ooh, that's so pretty. So the edge, we don't see the edge very well. This is sort of like me leaning over. Oh, look at the little boys. Okay, now. Up. The alignment means they sort of like they will tend to continue in the same direction. That's what makes them like reluctant to change their direction. So if we want like a more volatile flock, we want to This is so fun to me on a Friday night. It's some people might say it's sad. I Yeah, let's not get there. I think the alignment factor, right? So if I play with the alignment factor, if I'm happier with them being misaligned, there's kind of more. Let's lower this to like zero point 0.3, and then yeah, we're still gonna have some people, some of them caring a lot about alignment, but like we get more wider distribution centered lower. Of course, it's gonna affect the colors. Yeah. So what I've done is that red, green, blue, I've made like the likeliness of green become much lower, so we get all of those kind of purples. I guess it kind of makes sense, or am I deluding myself? I'm not seeing the effect of my stroke weight, and in fact, maybe I've messed up the color. So those colors should change because the fill is like the current vector rather than or maybe the stroke weight is too thick. Can I just say if I do stroke weight 0 or like no stroke, will that work? Right, now I've got my true colors and those colors, and still I'm in the purples, right? And those color crucially will kind of change and shimmer. Oh yes, this is what I wanted all along. Let's have bigger triangles. Oh yes, now they're a bit small. Yeah. We just need to let's make bigger triangles in render. I'm so excited. It's it is tragic. Align, cohesion, come on. Well, this was where I was in render, right? This is the thing I was, to be honest, I was a bit scared of touching with like the push matrix. I think this guy's going about it like, oh yeah, we have a nice, that's the radius. Well, it's just, thank God. Well, let's make larger triangles. Okay. Okay. Now you see the color changing a little bit as kind of different vectors have different priorities. We also notice that because those are the values after we. Ooh, wow, what's going on? Now what I could do, okay, is because I've done the stroke. Let's have a stroke weight of 2 and run it again. Now the edge is going to be a color that doesn't change. This is going to make. Yeah, this is earlier, undoubtedly, but more informative. So the outside color that doesn't change is like this sort of built-in sense of priorities. Now, again, they all kind of skew towards the purple because same deal. Okay, this is starting to slow down. I wish I had some metrics of like frame per second or whatever, but clearly that's not. But again, I also did, in fairness, do I need like 700 for the neighbor distance? I mean, that was probably a mistake, but I'm on a larger canvas, so I kind of I'll double that one rather than put it 700, and this might improve my speed. Okay, I've got an idea. I think we pass the location in the constructor and we build them in the thing. So if instead of this I do yeah, random is like built in. You don't need to import random. We're running Python, but like we're within processing. The code will run within like a much larger framework. That's why it's called a framework. So I think I can do like, this is my constructor, right? And I want like random, yeah, random width, random height, right? So they're all gonna be, this is gonna be interesting to see whether they actually flock together, like very much like birds of a feather. Random height, and if I just remove this, it's pretty flocky. That's a murmuration. I wish they okay, that's the thing. Then I've made them larger. I obviously need to increase my minimum distance, and this is what they call separation. Yes, desired separation, make that 50. Make that even 60. Stop it, run it. Now they're going to be created in different places. Let's see if they flock together. It's probably going to be creating smaller flocks. I'm not like affecting them, right? I'm not clicking in to attract them. You know what? I'm still gonna like take all of my changes and put them in the REPL. That work? Sorry, let's just cancel the history, go back here. Well, let's run it and see if that looks the same, and then I can paste that and put that like a description of the feed if I can find the right window. Yes, edit. Look at that. Oh, just yeah. All right. Oof. Very meta, editing the properties of the stream during the stream. Oh, did someone came and visit? Well, that's nice. It's more for the recording. Okay. This, and I've lost the window. Is that what's happened again? Sketch here. Sketch. Run. We were here, right? Now, perhaps because it doesn't seem like it's slow to render, right? It does seem like their motion is slowed because again we were dealing with smaller objects on a smaller canvas. So I think this have to do. There's like a point where we get where is it? We've got max speed and max force. Yes, okay, let's make, I mean, we've scaled this from 2 to 5, right? And like from like 25 to 50 or something like that in most places. So that, do I want to scale the max force? That's an interesting problem, right? When you model something. I remember when I was a kid, um, my dad is an agronomical engineer, right? So it's like irrigation and dams, and I don't think he's ever worked in dams, but dams are often mentioned as an example. And I was wondering why, like, you couldn't just kind of solve every engineering problem by first doing a model. When I discovered the concept of a model, it's like a smaller one, and then that works. And it told me because some constants don't scale. But the example he gave was like the viscosity of water, which is true, right? And things like surface tension and whatever. That's why it matches a smaller scale. But still, as a kid, I was like, just interested and confused. I understood what it meant, but it's like that's such a niche. I'm like, oh, the viscosity of water is like a physical measurement. Anyway, so this is about scaling, right? So we need to rerun it, and I've kind of changed the speed and force. They start in random locations, but because their max force hasn't changed, I could be a bit generous. Okay, are we moving this to 5? I feel like we're moving this to 5. Max force means they're going to be have more, like max speed means they're going to move faster. Yeah, max force is the acceleration, right? So they might be a bit more vivacious. We get some various colors. Ooh, I know what I'd like to do as well. I'd like to have is yeah, that might be too complicated. That's going to be too long to do on the live stream, but because I need to refresh my just like actual drawing functions of processing. Well, maybe I can attempt it, but it seems that although the flock is still quite scattered, it's tending into a definite direction upwards, and that it'd be interesting to have the average, you know, alignment, like orientation vector for each Boid, not only the average, but like some other metric, because the average doesn't tell us much. Well, it will tell us like where to point to, but it wouldn't really tell us much as to whether it's kind of a consistent thing. And then the average, and then maybe some degree of the like how the standard deviation of the angle. Wow, doing stats on angles, or wow, or something. How can I work that out? Well, let's do it. Let's do it. So that's actually a property of the flock, suddenly, is it? Yes, no. Can I access the? Yes, I mean everything is public, right? Those people are not really doing proper encapsulation, whatever, right? You've got your. This is programming for artists. Boom. Okay, I've got the. That's the angle, right? The angle is what I'm after. Self angle, random 2 pi. Well, that's the starting angle, obviously. So on the sum of like the Boids angle. Ooh. Yeah, but I'm gonna need like some kind of vector object or something. Well, I can use a. Can I use a Boid? I would need to parallelize the Boid and change its behavior. And in order to line it up, I'm gonna need a new tab on a new. Yeah, okay. Well, I can totally save the. I've been changing it, so surely I should be able to do. Yeah, save as in processing. That sounds like a good idea. New tab, and this is gonna be my vector. Vector. Lowercase for the file, but uppercase for the. Is that reserved? I'm gonna call it Victor. My vector. This will have an angle. Okay, it needs like a. So a constructor meaning that is self dot angle equal angle. That's the only thing I'm storing. No, is it the only thing I'm storing in my vector? No, I'll do like. Let's have the magnitude, because why not? I mean, I could have passed it at xy to be fair, and there's actually a p vector. There's like a p vector class in processing that does just that. But we had the angle, and then what'd be interesting is like the average or either acceleration, velocity, or indeed well, location, not so much. That would be like the center of gravity of the flock. But average of yeah, velocity, and so I need kind of like two mags. Well, you know, I can have like I can expressly say like vel, it's because it's to represent vel and ac and self dot vel equals vel. Oops, self no ac equal ac. So now I've got a vector that stores those three properties. I can hopefully it knows about that stuff, right? Well, it doesn't really need to even because it add Boids, Boid append, but it doesn't even know what those things are Boids, whatever. So in run, I will also not only call b run, but I have a. So this is. It's kind of like. This is just to store my average, so I need to work out the average somewhere else, right? Okay, so av angle equals. I mean, where do I start at? Because I'm going to accumulate into it, so I just want to av angle avac equals 0, av vel equal 0, and then in here I'm taking maybe every time we run we reinitialize, and then within the thing we sum. So av angle plus equal b dot angle, right? It's called angle. Yeah, no surprise there. And then feel free to watch all of the cool stuff on the thing. Can I just like make them flock to me? Look at that, they're kind of really racing. But it seems to still be flowing ever upwards. I wonder if I can manage to reverse that. Because once you get enough going, you get kind of enough going into one particular direction, hopefully they flock, right? Right, I got a spiral going. Let's see if it restabilizes. And the so I've done thrice. Acceleration. Sum it here, and then outside of the for loop, it becomes interesting. So how many? Yeah, I've got a len self void, right? So I've. Well, think about the average angle. How does that work? Because it's all modulo 2 pi anyway, right? So work this out later. Well, it's divided equal self. No, length of self dot Boids. There's so many places this can go wrong. So you know, there's been a lot of writing code. The next time I click run, it's going to be a nightmare of I'm sure fixing It's not even debugging, it's like fixing dumb stuff. And then finally devel. Now I've got this, right? And then I've got to work it out. I'm going to initialize a... I mean, I could probably do that. Yeah, okay. Vec equal, it's a vector made of those three things. So the average angle, which way does it come in my vector? Velocity acceleration, which is kind of like not consistent with this file, but well. So I've got my vector and I'm going to vec.render, and this is where the magic will hopefully happen, because in here I'm going to do for the time being nothing, so I can just check that all of my average code works. And indeed it doesn't, because what's going on? Int and p vector. Oh, hello. Those are all vectors already. Ah, yes, okay. So surely I don't even need the angle. Well, fine. I mean, it all works anyway, right? It's just like because it supports yeah, p vector. Oh, capital P, capital V? Yes, okay, because it's a processing vector. So acceleration and velocity are p vectors, but the principle, like p vector as a custom type, as a class, support addition because it's vector addition, and then that should all work. And then you finally divide it by a scalar. So that's what's your problem now? Ooh, because it's called velocity. Yeah. Called it fixing them stuff. All right, okay, what's going on here? Global name vector is not defined. What do you mean? It's like called vector, and I've got it next to. How does that even work? Are they? Is this saving? Ah, do I need? Have I saved? Now that's saved. Now we can load it. You'd think it would save before it runs. No. Do I need to import? I don't know what I'm doing. Well, what's your problem then? Okay, so how about, you know what? Okay, I didn't want to do a file in the first place. So you know what? I'm not even. Can I like rage quit the tab? No, fine. Well, okay. So instead, yeah, that definitely does the flock, right? But above that, we still have the vector, because why not? And then now it should work. Oh, it did work. Okay. I'm the first one to be extremely surprised. Now we don't see anything. Oh, they do start flocking. Yes. Ooh, this guy. What's happening with like, so red means priority to separation, so like doesn't want the neighbors. But the fact that it's very black is there's not many forces acting upon it because it's far away from its neighbors, right? Again, the little radius of. Now you'd wish there was like you see them flicking because like they come in range. It's a fixed radius. You wish there was like you wish, I for one could wish there were like an inverse square law where you more or less affected, like it's not, it's not on or off, right? You understand what I'm saying? With my hands and off, but that would be like like even more computationally expensive. Yeah. Still, I mean, it works neatly as it is. Now, I wanted to have my vector. So tell you, I'm going to steal the Boid rendering code and just chuck that at the, it's here. And then it uses the location and then, okay. So in render, with is a context manager. Don't sweat it. Instead, we're going to go to, this is where we're going to use, width. Do I have access to width and height from other places? I'm not sure. Oh, this is so annoying. Oh, please tell me I'm not going to need to. Oh, thank. Okay, half the width, half the height. So the middle. Rotate theta. Yeah, so I kind of want to represent something. I want to take self-angle. And instead of self-r, can I? No, it doesn't. Can I? Yes. 10. Find previous, replace. Find, replace. Find. I wish you could just click replace and it would forward as well. Oh, okay, fine. Yeah, right. We could have written 20. You get it. Well, or yeah, as bamboozled as I am. Right, that's my so okay, so this big weirdly it's get so the colors come from like the last Boid that was drawn. So there's like one Boid in the flock, that's the last one in the array, and this will have kept like the fill and the thing. So I believe that this is the angle, so this is the average orientation of the whole flock. It's not massively interesting, looks like surprisingly consistent, almost as if my thing was broken. Ah, it's changed color. Okay, so I have a triangle. I mean, it doesn't look like it's moving, right? It's yes, it's very much not moving. What's theta in that context? Oh, right. Velocity heading to the right. Okay. Ah, okay. I might use this instead. So I'm in flock. I'm in my render method on my vector class, a flock, and instead of self angle, ooh, okay, self vel, and it was heading to the, yeah, I can work with that. Bracket. Ooh, yes, it's moving, isn't it? Okay. Ooh, what is going on? It's moving a little bit, is it? Or, well, it's definitely not pointing the same way that it used to. Oh, you can see, like, because I'm creating one, when I click, definitely get the colors of the one I've just created. Now, I don't think that this is the actual the heading of my velocity tree. Have I forgotten to reset my accumulator of the way I've done the angle? Every run, we set it to 0 or recreate it, and then we sum it in, and then we divide, which, for a vector, so all the stuff I'm manipulating, okay, the angle, that's a real number. Oh, I see what's happened. The self angle, that only really, that's only used within the constructor, as far as I can see. Oh, surely, right? Okay, come on, we can find it. Yeah, triangle. So, okay, yeah, we don't need self angle. This is just a helper function. It's just so you help a variable. It's not like a permanent attribute of the class. It's very misleading. That's like that. You use angle so that you get your one random angle, and then you use this to build your velocity vector, and then you're home. Right. So that means that I don't really need to worry about angle. Well, I'll keep it because I don't want to have to delete a whole bunch of code. Um, let's work with the velocity. Velocity heading 2D. I've summed everything. And you sum that. I mean, the beauty of the vector is like it's just the sum of the vectors. So it's just a sum. I don't even need to average because that doesn't really. I mean, it will change like well, At the moment, I'm just focused on the angle. At some point, I may want to have the size, it's getting a bit late, may want to have the size changing. And if I do, I will want the magnitude of the vector to have been scaled down and divided by the flock. But at the moment, I can live without all that. Well, actually, the angle, okay, there's the little stuff to do with the angle, because if I'm stopping there, I want to leave the file in a relatively healthy state. Then I'm going to comment that out and initially want the angle. I mean, who's we here? Me and future me. Okay, save that. Right, so what is happening? Flocky, flocky. So I'm currently, like, the big pointer in the middle is currently giving me the sum of all of the velocities, which should be like, because that's the direction in which they're moving. So, you know, that's because they will always be facing forward, right? You will not see them drift. Um, in that we work out the direction and then it's drawn based on that. So that's what if I make it the, okay, where am I? Instead of vel, let's have ac. No, or do I need two vectors? Or no, I need to render two triangles. Okay, so if I did this, right? Fill black, stroke like light gray. I'm gonna do the vel like I had, and then if I just look, I can do this. It's gonna work. And then the ac, right? Fill, and then it's different stroke. They're kind of gonna overlap each other. So I think fill 0 will. Can I just like get transparent fill or no fill? Is it no fill? I'm sure it's no fill. I'm gonna chance it that it's no fill because it's so quick to restart the sketch. Do I have 2 arrows? I don't have 2 arrows. Victor, what's happening? Oh, the angle. I still get some bit left over from the angle. Yes, so I'm still dealing the angle in the constructor, which means I need to change this to remove all references to the angle because I blame either Daniel or Craig, clearly, on the fiasco of the angle. Look at that. Oh, it looks like, are my 2 arrows overlapping? They shouldn't. There's no reason they should be. I mean, there's definitely fill 0 and stroke like the other one. Oh no, they're both 200. Well, I mean, I'm sure I should still be able to see them. No, well, no, why not? Okay, let's say it's oh, it's 8. My screen's going so it's like, okay, so I think I'm looking at the arrow for the acceleration. Oh, certainly that this one shifts much more the moment I stop clicking. All right, I think we're done here. Like, we're done like an hour or something, maybe a bit less. I will be back for some processing fun. Let me just. Okay, well, I'll do it in. Fine, I'll do it file by file. So in Flock, not this one, in Flock.py. Yeah, this is where I've put my vector, Victor the vector. Let's switch to nothing in the Victor file. Then in that's my Boid, right? Yeah. And I could do this offline, but I won't. So what? Have I changed anything? And it looks like it's the draw background 50. Background 50. Yeah, that's the same, isn't it? Okay, so that is it. Oh look, I can do a fade. And oh yes, and then I will leave you on this. Good night. Ah, brilliant, excellent. I think the sound is still on though. So how do I turn this off? Hello? What? Stop.